Okay, we're now going to look at the domain and range of a function. Okay, I want you to recall what we learned earlier about functions. Okay, so for a function, every x value has a unique y value. So that's what the definition is, a special kind of relationship where x values have unique y values. Okay, and recall that when you have an ordered pair, the x, the y, the x is the domain. The x is, when we talk about domain, we're looking at the x values. It is the independent variable and it is the input, while the y is the range, the dependent variable, and the output value. Okay, so when we're talking about domain, we're going to look at different situations. The first situation we're going to look at is ordered pairs. Okay, or points. So when we're given a set of ordered pairs, for example, 3, 7, 2, 4, 1, 5, okay, 0, 7. This is a function again because notice how the x values are unique. They do not repeat. They have unique y values. So here, if you're given an ordered pair, the domain is just all the x values. Okay, so the domain are all the x values. Okay, so 3, 2, 1, 0. And the range are the y values. Okay, so the range are the set of y values. We have 7, we have 4, and we have 5. We don't have to rewrite that 7. We've already shown, represented it. So that would be an easy problem. That's something we consider an easy problem. Okay, how about if you have a table? So right here you have a table of x and y values, and this is, let me make a table of functions. So 0, 1, 1, 2, 2, 3, 4, 5. I'm just making this up as I go along. 6, 7. Okay, so all our domains are going to be the set of x value. So domains, I'll put D for domain, 0, 1, 2, 4, 6. Our range will be the set of y values, 1, 2, 3, 5, 7. Okay, what if we have a graph? Okay, so number 3, let's make a graph. Let's make the graph of a line. Okay, so here's my x, here is my y. Okay, here's my x, here is my y. Okay, and let me make a line. Let's try to make a straight line, so I'm going to use my tool here. Okay, make this line right here. Okay, so now we want to figure out what is the domain of that line and what is the range of that line. Okay, so we're trying to figure out the domain and the range of my black line. Okay, so domain. Domain is the set of x values. What is the graph doing for the x? The way I like to look at the domain is I like to take a straight line, a straight edge, your pencil, your pen, whatever you have, and I want you to do something like this. Okay, so I'm going to use just a regular line, okay, to represent my ruler or something that's straight. Okay, domain is the x. Okay, so domain is your x-axis. I want you to take that straight line and then run it across the x-axis. Run it from the beginning. as you see, when you start out on the X, so domain represents the X, so you're taking your ruler, your straight edge, whatever it is that you have, you're running it across the X. Okay, so where you start, notice you hit an arrow. On the X, if you're looking at your graph and you're going from left to right, which is represents your X, you start out with an arrow that goes on forever. So it goes on forever in the negative side of the X, because remember, this is the negative side of the X. It goes towards, as you go towards the left, you're going more and more into negative infinity. As you go towards the right, you're going more and more into positive infinity. Okay, so your domain, this is a notation that we use. This is more of an advanced algebra notation. You start at negative infinity, so you put negative infinity. Okay, notice how I'm using parentheses. Sometimes you use parentheses, sometimes you use brackets, but for infinity, you always use parentheses. Okay, so you start out right there at infinity. Okay, and then you go, you keep going, and then you notice how your X line does not end. You end up hitting another arrow, just like that. Okay, so you end up hitting another arrow just like that. So that means that it ends at positive infinity. It doesn't end. It goes on and on and on and on and on forever. Okay, so that's your domain from negative infinity to positive infinity. So on the X, the line goes on forever. Okay, so let's look at the Y. What happens with the Y when you're looking at this graph? Okay, so let me create my makeshift make-believe ruler. Okay, so here is what I'm gonna pretend is a ruler. Let's see, shape. We want to insert shape. I'm gonna insert another line again. And this time I'm making it a horizontal line to go with my Y. My Y is vertical, but you go up and down the Y's. We need a horizontal kind of positioning so that we can go up and down, up and down. Okay, so if you take this ruler that's horizontal and you're trying to move it up and down the Y, moving it up and down the Y, notice that to start, so you go from bottom to top. You start out with an arrow, so that means that the line goes forever and ever downwards, which is negative infinity. Okay, so the line doesn't have a start. It kind of goes into a deep hole forever and ever and ever. So it's negative infinity. Okay, and if you go up, you hit an arrow. So that means it goes to positive infinity. Okay, so it goes to positive infinity. So that is negative infinity to positive infinity is your range. Okay, so let's go ahead and look at other graphs to see all the different things you can do with this lovely graph. Okay. Okay, I found us some more graphs to work with. So let's look at A. Look at A right here. We're looking for domain and range. Alright, so I'm going to put D for domain, R for range. Let's get our tools here. Alright. Okay, so for domain, you go side to side. So you want to take your ruler, your straight, whatever is straight, your straight edge. Okay, and you want to draw a vertical line because you're going to be using it to go side to side. Okay, so if you start from the left, because we always read from left to right. So you start from the left, and the first thing you hit is an arrow. That arrow tells you that on the X, okay, the arrow tells you that towards the X, you will be going forever and ever. Okay, so if you're going side to side and the first thing you hit on the graph is an arrow, that tells you infinity. Okay, now take the same arrow, you take the same tool, you go from left to right. The last thing you hit as you go from left to right is an arrow, so that tells you you are going to positive infinity. It's going on forever. Okay, so this is That's excellent. Okay, and notice how again I use bracket, I use parentheses. Whenever I have infinities, I always use parentheses. So there should not be any confusion with infinity. You will always use parentheses with arrows that go for to represent infinity. I'm gonna put this tool on the side so that I can use it later. Okay, and let me get a horizontal tool so that I can go up and down with the horizontal line. Okay, again, you use your ruler, what, or you use your hands to do this. Just use your fingers and just go across the screen. Okay, so now we're gonna do range. Remember, range is the y-axis. So to go up and down the y-axis, you want to put whatever your tool is to be in a horizontal position. Okay, so when you start, you go from bottom to top. Go from smallest to biggest, bottom to top. As you can see, if I'm going from bottom, the first thing I hit on the graph is an arrow. That tells me the first thing I hit on the graph is an arrow. That tells me that I am going from negative infinity. Okay? Then you take that straight whatever it is and you go all the way up till you hit the very end of the graph. Okay, this is where the graph ends. There's nothing else after it. This is where the graph stopped. Okay, and you look at your tool and notice that on the y-axis, the only place it crosses, that number is 3. Okay, that number is 3. So that means that this graph is going from negative infinity to positive 3. It's going from negative infinity to positive 3. Okay, and so let me do this. So this is going from negative infinity to positive 3, and it doesn't want me to get my lines anymore. Okay, so that's no problem. That's okay. It's going from negative infinity to positive 3, and notice that that 3 is, there's no hole on the 3. Okay, so that 3 is included. There's no hole there. So whenever something is included and it's not an infinity sign, you use brackets. So bracket. So it's negative infinity to 3 bracket. The bracket tells you that the 3 is included. Alrighty? Alright, let's do more. Take my tool. Okay, it's going to be really difficult to move around my tools. I'm putting my tools right here. Alright, so let's do the next one. Domain. We are going to again use the tool side to side, domain from left to right. Okay, if I'm going from left, the first thing I hit on the graph is right here at negative 2. So that means we start at negative 2. And notice that there's a hole right there. It's like a circle with a hole on it. So whenever we have a hole, it's parentheses. So we start at negative 2. Okay, and we go from side to side all the way here. Okay, since they didn't tell us what that point is, I'm going to assume that it's an arrow. Okay, so I'm just going to make it an arrow and assume that it is. That's what they're pointing at. Okay, so that means that it's, you hit an arrow, that means it goes on forever, so it's negative 2 to infinity. Infinities always have parentheses. Alright, now we're going to do for our y. Remember, y is from bottom to top. So if we're going from bottom, we keep going, we keep going. The very first thing I hit right here is right here. You got to be very careful with this. So your line is on the y is actually hitting right here at 0. So if you're going up and down on the y, you're hitting the origin. Don't confuse that with the negative 2 because you're not actually hitting negative 2. The negative 2 is on the x. You're hitting right here, which is the origin of the graph, and you know the y value and the x value at the origin is 0, 0. So your y value is 0. Okay, so you're starting out at 0. Okay, but this is going to be very confusing. But notice that there is a hole right there. That place where it starts, that point is a hole. On the y is at 0. if you're looking on the y, is at 0, but that point is a hole. So that's why we have parentheses. Okay, and I'm going to go ahead and erase this part of it because we don't know what that is yet. Alright, so we now take this again, we keep going up the graph, going up the graph, going up the graph, and notice on the y you are hitting positive 2 and there is no hole right there, and there is no hole right there, and therefore it ends at 2 and the 2 is included, so you use a bracket. Okay, so I'll tell you the answer to C and I want you to prove it to yourself. So for C, the domain is negative infinity to positive infinity. And the range is negative infinity to 8 included. Okay, so that's for you to prove to yourself. Okay, let me write a few notes here. So if you have a hole, you want to use parentheses for the point. Okay, so for example, let's say that we have this graph where it's like negative 1 to 1, 1, 2, 1, negative 1, 2. Okay, and the graph looks like hole, up, down. Oh. So the domain here, if you're going from side to side, you have that line going from side to side, the first thing you hit is a negative 1 and it's not included. So it's a parentheses. And then you go from side to side. If you look, the next thing you're gonna hit is at 1 and it's not included. Okay, and then the range would be, if you're going from bottom to top, this is negative 2. Going from bottom to top, the first thing you hit is this hole at negative 2, and then you can go all the way to top, and you see that the 2 is not a hole, so that is a bracket. So no hole is a bracket. Bracket. That is, I don't think that's how you spell that word. But it's a bracket, so I'll say brack. That way you don't see my poor English skills. Okay. Now let me highlight something. No hole. Wow. No hole. Bracket. That's why I have this bracket here, and because there's no hole here. Hole parentheses. Okay, hole parentheses. That's why I have this here. Okay, because for the range, this is a hole. So I don't want to. That's a hole. I don't want to fill it in. Okay, so I hope that made sense to you. And every time infinities are always use parentheses. Thank you. I hope that makes sense to you. Thank you.